Hi there. Let's discuss about magnification in the case of curved mirrors today. And what we have here is the image formation in the case of a concave mirror. Okay, so we see that the concave mirror is forming a real image in this case. If we look at the images, we see that the object here is upright, whereas the image here is inverted, right? So if you call HI as the image, HI is going to be negative, whereas the object HO is going to be positive. Okay, so what's magnification? Magnification is defined as the height of the image divided by the height of the object, and we will put in the sign conventions that we briefly discussed. That means minus HI divided by HO. So the overall magnification value which we get is going to be negative. Okay, so to summarize, if we are having a real image in the case of mirror, then the magnification is going to be a negative value. Now let's discuss the case of a concave mirror, and that too virtual image formation in the case of a concave mirror. So we have the concave mirror out here, and the image, we have an object which is placed in between the focus and the pole. That's the place where we get the virtual image. And we see that the reflected rays are not going to meet, they are diverging, and therefore if you extend the lines, they have the object, the image which is going to be formed, and as we see here, the image is going to be a virtual image. So if you examine the size of the object and the size of the image, we see that the image is going to be erect. Erect means positive. Likewise, if you see the object is always erect, object is also positive. So when we look at magnification, definition remains the same. It's height of the object by height of the image by height of the object. But here both of these are positive, and therefore magnification ratio in the case of a virtual image will always be positive. So please remember this. It's also possible for us to correlate magnification with respect to the image distance V and the object distance U. Okay, so we define magnification M as minus of V by U. Okay, so the minus is built within the formula, and V and U are the image distance and the object distances. Okay, so finally magnification M is the height of the image by height of the object, also equal to minus of V by U. So this particular relationship is very useful for us to solve numericals with the concave and the convex mirrors when magnification values are specified. So let's tackle a problem of that type now. So let's solve this numerical now, which is based on magnification values, right? So let's read the question. What does the question say? Find the distance where the object is placed. Okay, object distance for an object of height 2 centimeters, right, which is placed between the center of curvature and the focus. Okay, and you're getting an image of height 4 centimeters, and focal length of the concave mirror is 15 centimeters. So this is the data that has been given. Okay, so we have not been given image distance, we have not been given any other data other than this. So let's first document the data that is given to us. Okay, so what is given to us is the height of the object is given, so we'll call it as HO, height of the object. How much is it given? It's given as 2 centimeters. Okay, and we have been given height of the image, right? Height of the image is given as 4 centimeters, right? So we see that it is a magnified image. We have also been given that it is a concave mirror, right? So what is the focal length of the concave mirror? It is 15 centimeters given. So do you remember what is the sign convention in case of a concave mirror? So concave mirror is this way. Therefore, focus will lie on the left hand side. Focus is going to be negative, so we put minus. Okay, and where is the object placed? Object is placed between C and F. These are the data that is given to us. Okay, so we will employ the relationship which we discussed in the last section, that is magnification M is equal to minus of V by U. This is a formula that we are going to employ here in order to find the distance of the object. We are supposed to find U. This is the question. What is U? So for that we will use M is equal to minus V by U. Okay. Now what is M? M we know is height of the image by height of the object. Okay. So we know that M is nothing but height of the image by height of the object. Okay. From the data we see that height of the image is 4 centimeters. Okay. But is this going to be a real image or an inverted image? So that's the question that we need to address up front. Okay. So what is going to be the image type? Is it real or is it inverted? Real or virtual? Now, is there anything that is given in the question that will help us to answer that? Because unless we know the type of image, we cannot find out whether magnification is positive or negative. Okay. So the smart fellows amongst you will know that this is the clue. The object is between the center of curvature and focus. Okay. So when that object is in that position, then we know that image is going to be magnified and real. Okay, so they may not all the time specify, they may just give a subtle data point here, and we should use the knowledge of our object positions, ray diagrams, image positions in order to solve these numericals, right? So when the object is placed between C and F, he is indirectly telling us that whatever image you are going to get, it is going to be real, it is going to be magnified. Okay, so if it is a real image, we have seen in the previous section that magnification has to be negative. Okay, so we will say this is minus of height of the image is going to be 4 because it is going to be inverted. Height of the object is 2. That means this is going to be minus 2. So magnification is simply a ratio. There are no units there. We have calculated M is equal to minus 2. Is it fine? So now let's move to the next part of the solution. So we have M is equal to minus 2 and we have F is equal to minus 15. Focal length was given as 15 centimeters, minus 15. We employ the formula that we are aware of. 1 by F is equal to 1 by U plus 1 by V. This is the formula we can use to calculate U and V. Okay. Also, we will use the relationship M is equal to minus V by U. Okay. So magnification we got it as minus 2. That means minus 2 is equal to minus V by U, or we can say V is going to be equal to 2U. So if you look at this, whenever they are giving us the value of the magnification and they are asking us to calculate the object distance or the image distance, the thing that we need to do is first one compute magnification with the sign properly, and then use M is equal to minus V by U and develop a relationship between V and U. Okay, so that is going to be the first milestone for us. We need to get a relationship, and then we use this relationship in this. Okay, so we say 1 by F is equal to 1 by U plus 1 by V. V is nothing but 2U for us. Okay, and then we can put the value of F as minus 15. Therefore minus 1 by 15 is equal to, if we simplify this, we get this as 2 plus 1. 2 plus 1 by 2U, or equal to 3 by 2U. Okay, so now we have minus 1 by 15 is equal to 3 by 2U. We can readily find out U. Okay, so we will write it here. Implies U, we take it that side, U is equal to 3 by 2 into minus 15, which is going to be minus 45 by 2 minus 22.5 centimeter. So U is going to be minus 22.5 centimeter. So does that tally with our object and the position of the object given? Yes, it does, because focal length is minus 15. So the center of curvature would have been 30 centimeters. So our object is between the focus, center of curvature and focus. So that means the answer is tallying with the data that is given. U is equal to minus 22.5 centimeters. I hope you understood this question. Thank you so much for watching our videos. Please like and subscribe to our channel. Be sure to share it with your family and friends. And don't forget to visit our website www.cogitarelearning.com, where you have linked to all the videos that we have been recording so far. Thank you once again.